Picking up where we left off, I wanted to put a little more emphasis on the remarkable pricing now of solar photovoltaic utility scale uh, production. You can see the numbers here. It's $31 if you're on a cell phone and the screen's too small. And then wind is $26. These are prices per megawatt hour. But don't worry so much about the units. It's just a relative thing because what we're comparing them with are the kind of standard, natural gas peaking plants, nuclear plants, new ones, a new coal plant, or a new natural gas combined cycle plant. And we can see that in all cases, these are quite competitive. The brown ones we said were prices of just the fuel of operating costs, to generate another megawatt hour. Not including the financing and so on costs of these. So these are more or less just fuel, including operating costs. So very competitive here. And just to review something really, really quickly, it wasn't always that way. Even 10 years ago when I was teaching this kind of stuff, how do we beat climate change? How do we go to a low carbon emissions kind of economy? We're going to need solar and wind. And solar was just unthinkable, really, anywhere, except maybe the Southwest deserts a bit. And wind was still relatively expensive. And now we have a situation where that's not the case. And both of these examples, the creation of a global market by a handful of countries, Germany, Denmark, United Kingdom, Spain, Japan, to some degree the United States. And then later on, about 10 years ago, China jumped into this story. But they wanted to have domestic leadership in these industries. So they knew one way to do that would be potentially to create huge internal markets for those. So they guaranteed prices to producers for the electricity they produced. And so for a long time, Germany had more solar installed than any other country in the world, even though it's not a very sunny place. So in some sense, then, it was really the consumers and the governments who had to kind of pony up and make this happen. And not everyone was happy, but they gave the world a huge gift because the developing parts of the world now can have very low-cost solar panels and wind turbines as well. So really a tremendous story there. So where we're at now, though, is we want to have a peek at where we appear to be heading in our region in terms of production of energy and use. And there's largely, I would say, three trends that most people who look at this sort of thing would point out. And to a large degree, these are happening everywhere. We have our own kind of story here, but to a large degree, again, these are the same everywhere, just different mixes in different ways. So efficiency, just defined as less energy used per amount of services provided. In transport, for example, automobiles, right? Miles per gallon, okay? How does that get determined, what auto manufacturers produce? If you just leave it to the market in the United States, because we've had pretty low-cost gasoline, there's a trend. If you look at stretches of years where the auto manufacturers haven't had requirements, they tend to build more powerful vehicles, greater acceleration and that sort of thing. And they don't emphasize at all fuel economy. Very few people buy an automobile based on fuel economy as a primary criterion. So what happens is we've had it over a long period of time, beginning in the early 70s, a stretch where when fuel would get expensive, people would start buying more energy efficient vehicles, but it took a while. And so, for example, the Japanese manufacturers were real good at making lower fuel use vehicles and more efficient vehicles. And so they did real well in our market in the late 70s and the energy crisis and so on. So, but one way to do that is through policy. Recently, the Trump administration has rolled back some of the fuel efficiency requirements for the auto industry. But a bunch of states who really wanted to do better than that have banded together with California, Washington, and Oregon are in that group. And there is a number of other states. I think there's maybe 17 or so. Don't hold me to that number.
who have decided to have a higher standard for that. And so we'll see how that goes now with a change of administration. But the standard was set real high. It was a challenge, and the auto industry didn't like it. They've always resisted that sort of thing. They always said they can't do it. They've always been able to come through. There's careful study that goes into those regulations, but still the norm. Buildings, another thing of efficiency. We lose a lot of our energy in our economy by heating and cooling buildings, ones that are inefficient. And so through heating and cooling, then having more efficient systems, and then also doing a better job of insulating, sealing, and so on. And so there's a lot of effort that's gone into that in the last 10 to 12 years. And we've made progress in those areas, and our economy is more efficient related to that. Another one is decarbonization, just means reducing carbon dioxide and methane emissions from energy utilized. And the methane, by the way, when it is emitted, eventually ends up being carbon dioxide through time. So methane, in this sense, over the long haul becomes carbon dioxide. So I'm kind of using, decarbonization in that context. But there's also carbon in methane. So several of the points to make on this. To do that, there is a consensus with people in the science community that we really need to get more serious about this. Still, globally per year, we're seeing 1 to 2 to 3% increases in the amount of carbon dioxide emitted over the previous years. If we're going to reverse climate change, we need to go the other direction. So why would we be making new fossil fuel electricity generation capacity? And in a lot of countries, that's still been happening. It's happening in the United States with natural gas right now. Okay. Remember, the story there, though, is that natural gas is basically replacing coal. As natural gas is more flexible, the cost per kilowatt hour is similar to coal, maybe a little less in some settings, depends on the geography and the technology. But the other thing is it can be turned on and off easily, that some of the gas plants can, whereas the coal plants cannot. They pretty much are just a base load 24/7 putting out that power. The second, we need to then just say no to new in this case. Just say no. The second part is to phase out fossil fuel-based electricity generation regionally. And so, in fact, we're seeing some of that happen. I mentioned the closure of the plant in Boardman, the coal-fired plant. But at the same time, we've increased our gas use a lot, in the natural gas use in Oregon a lot in recent years. And so we're going the wrong direction on that. And so related to the purchase of natural gas, and by the way, as we said, it heats our homes and our buildings too, is to phase out fossil generated electricity purchases. So in other words, if the degree to which there's fossil fuels used in generating electricity we're buying in Oregon through the various utilities who do that, that obviously, if we're going to keep decarbonizing, needs to change. And so we got to, in Oregon, the challenge, as I said before, something to make a point on, we do buy coal-fired electricity in the winter from states to our east when our hydropower supply is relatively low, okay? So there's a seasonality to that. And then we've got that challenge then on this one here about what to do about natural gas building heating. So whether it's homes, businesses, and so on. It is a low-cost way to heat. The use of a heat pump is an alternative, and a heat pump uses electricity. Now, if the heat pump is using electricity generated by natural gas, we're better off just using the gas to do it. Thank you. But heat pumps have a high capital cost up front, but a lower operating cost. So you have those trade-offs, and they can be used both. Most of them are dual purpose. They can not only cool your home in the summer, but warm it in the winter. Here's the problem. When they build a new home, if they put a natural gas water heater in the garage and a natural gas furnace, wherever it goes, wherever either of those go, the furnace and the water heater, once you put those in a home, of course, if you're building a new neighborhood, you've built out the gas pipelines and all of that. Once you've done that, you kind of lock yourself in. Imagine you have an air conditioner, which runs on electricity, but it hooks up to your furnace, which is a gas furnace in most cases in most cities. What will happen is eventually one of those units will fail. It might be the furnace blower, or it might be the compressor and the air conditioner, whichever it is of the two. Are you going to replace the whole thing, including, the blower if it's the air conditioner and so on? So you got to replace both, because if you don't, you kind of go back to the same status quo. So once you make that decision, then build a home with natural gas heating of water and air. It's pretty well locked in, and it will last for many decades. And yet there's no strong initiative, for example, in the Pacific Northwest states to stop doing that. We're not serious about climate change if we're putting new natural gas infrastructure into our neighborhoods, because people get locked into that. So that's a policy kind of question, for example. All right. I have nothing against natural gas per se. It's what I use in my home because that's what was there when I bought it. Okay. But that's the problem. So I'm kind of looking, okay, when this is replaced, do I go get a heat pump? Okay. And the heat pump, the capital cost is higher, as I said. So, it is a big decision, but again, the operating costs can be very reasonable, especially in typical temperatures on the west side here. So if you build new infrastructure out that is focused on natural gas, you lock that in. Not a good idea. Need to have more concerted political efforts in that regard. Electrification is the next piece. All right. So decarbonization, how to get rid of carbon emissions, basically stop using fossil fuels over time. And these are some ways that can happen. And then electrification. I'm going to go to the next YouTube on that. So we'll just stop this one here and we'll go to the next YouTube.